rechargeable battery. This is a 12 volt 7 ampere lead acid battery. As you can see here, it's a 12 volt 7 ampere lead acid battery, which is commonly used in computer, UPS, and such applications. This is a very good battery for the purpose of rechargeable fan. And the next major component is a motor. Here I am using somewhat a fancy model motor, which is already fitted with a mounting shield and something like that. If you like, you can use a 775 motor also, but the RPM of such motors are very high, so you need to use some geared motor or something like that. This is a motor which have an RPM of maximum 5000 or 6000 RPM. It's good for applications such as fans, coolers, and all. So these are the prime components which we need for this build. Other components which we are using here is, this is a PWM motor speed controller with a switch at the end. So you can see there is a switch followed by PWM speed controller. It can be used to up to a DC voltage of 30 volts. Blades which we are using here is a bigger one. This is a 12-inch cooler blade, water desert cooler blade, which you can get very cheap rate, approximately at a price of rupees 50 from your local hardware store. Stand, I am using a combination of some metal rods. These are rods which I have removed from my old sweeping mop which we used to clean the floors. So I am planning to build a telescopic attachment to the fan so that I can adjust the height. That's why I am using such a hollow pipe. You can use some good quality high grade PVC pipes also, or you can use a solid metal rod if you need not to adjust the height. At the end I have heated and friction fitted a 3D printed mounting bracket. The other telescopic end of the rod is will function like this, so it will work in a telescopic manner. The fittings are not completed. We will attach some fitting at both the ends of the rod in order to reduce this shaky moment. For the base, I have 3D printed a beautiful base panel. This will act as both the base panel as well as the mounting container for our battery. So you can see it is printed at the exact size of this battery. It will fit perfectly into this mounting bracket. And the upper end, we will be providing a shield for the battery. This will act both as the shield as well as the support for our mounting rod. Here also there is a housing for the mounting rods. I will show how it works. See, these 4mm long bolts will lock into the base just like this. And provide a grip as well as work as the shield. And I have just mounted it in the wrong direction because the battery terminals are covered now. So the battery terminals will be exposed in order to avoid some circumstances of excess heating followed by a burnout. So it will be exposed here. Here we will be attaching the control column at this chamber. Here we will be fitting all our switching units and other attachments. Mounting these washers at ends of the rod to smoothen the movement of the rods. Now let's mount the washer for the inner end. So the inner end washer will mount it like this. We will be mounting a tilt assembly also. So this is the mounting for the motor. We will attach the tilt assembly to this point. This is a housing for a M4 nut, so that the nut won't rotate around once we fix it. Now we will use a 4mm nut followed by some washers. This is to free the movement of the, this is the locking knob. It is also equipped with a M4 nut at the inner side. So this will get locked like this position. Now let's attach the motor. So it is provided with a motor mounting. We just need to screw it up. So you can see this is mounted perfectly, and we can lock the angle of operation with the help of this knob. Let's install the battery first. So before that, we will place these rubber bushes. This will benefit us in two ways. One is that this will reduce the jerk and vibration due to the rotation of the motor. Another thing is that the battery, which is a substance which get hot often, will get ventilated in a better way. So the battery is placed. So here, as you can see, both the terminals are welded. Now we can attach the upper shield. One thing I forgot to, the shield is also provided with these cushions in order to increase the level of ventilation. Let's move on to the wiring part or the electrical part. So this is the basic wiring of the switchboard. This will be the master switch, that is the output from the battery will be regulated using this switch. This switch is an optional switch for the voltage display. I am installing a voltage regulated display or voltage display in order to monitor the voltage drop and the peak voltage of the battery, because it is very necessary to monitor the voltage of the lead acid battery, because our draining may permanently damage the battery. So this switch will be connected to the display unit, so that if we need to switch off the display at any point of time, we can use this switch. This is a two-way switch. It will be connected to a DC out for our tube lights. I'm also using these tube lights as a backup power supply or backup supply for the light purpose. So we can take a DC out to use these DC bulbs. So here it is a two-way switch. We will use two different intensities. We can use two different intensities using this two-way switch. So this will be the ground for rest of the connections, because the ground is connected directly to the PWM controller. Now let's turn the slot. So this will be the positive. So the positive of the motor. So this is a red wire. So this is the positive and the positive. So negative of the motor is also connected. So all our connections of the PWM is complete. Now let's place it into its slot, lock it with the help of this nut. Since we have completed the basic circuits and connections of a rechargeable battery, now we will be connecting some add-on components. One of the add-on component which I am using is these two DC out jacks. These jacks will be connected to the battery so that we can take the DC out for something like a DC tube, DC LED strip or something. Another add-on which we will be using is this voltage display monitor. This is a tiny and cheap voltage display monitor which can measure up to 30 volt DC. We'll start the assembly of our DC out jack. So this is a chamber which I have designed and 3D printed for our DC out jack. Now let's check it. Yes, it's working perfectly, smooth and fine. This is a housing for LED display. Let's place it gently inside it. This is a very delicate device. As you can see, the back side is equipped with some integrated circuits and chips. Also accidentally forged onto the board. One of its pin got damaged, which I have fixed after a lot of efforts. So need to place it very gently so that it won't get damaged again. So the housing is secured with a top lid, the channel logo printed onto it. The lower platform of the display unit is going to be the cover for this jack. Yes, it's working fine. The positive terminal of our display is connected to the DC out from the switch. The negative terminal of both the DC out jack as well as the display are connected together because the ground is common for the connections. These are the two DC outs. One is on the energy saving mode, the another is on the full energy mode. So we will be connecting both of these ends to the DC positive jack. So as of now, fan assembly is complete, and this is what it looked like. It's marking 12.1 volt. It's 12.7 volt in fact. Motor speed controller is provided here to switch on, as well as to adjust the speed. Here you can see. Since we have tested the motor and the fan, now let's check the DC out pins. So this is a DC LED strip which I have purchased. The operating voltage is 12 volt. So I'm going to connect it to the DC out jack of this, and you can see this is the energy saving or the sleep mode, and this is the powerful 12 volt full flex daylight mode. So this is the display. Let's have a closer look. So here I switched on the display and it's showing 12.7 volts. Now let's switch on the fan and see the voltage drop. So this is the voltage drop when the fan is being operated. And switching off the fan, the voltage comes to normal. So this is a static voltage of our battery.